Hi everyone, this is Mrs. GA, and today we're going to be starting kind of an intro to some statistics. So we're going to talk about data gathering techniques, shape, center, and spread of our data. All right, I have a quick warm up for you guys. So if you could pause the video and give it a try, that would be great. All right, so here you can see I have my tree diagram. So my first layer was whether or not they had the mutation. So again, 1% of the mice actually have the mutation, so 99% do not. And then of those that have the mutation, so a test for mutation correctly identifies mice that have the mutation 98% of the time. So that's saying given they have the mutation, 98% of the time they will actually test positive for it. And then it says the test correctly identifies the mice that do not have the mutation 96% of the time. So given that they don't have it, they will test negative 96% of the time. So here the lab assistant says that the mouse tests positive, so she's going to assume that the mouse must have it. Is this a good conclusion? So to decide this, we should figure out what's the probability that they actually have the mutation given that they test positive. And again, that's the condition because it says the lab assistant finds that they test positive. So again, given that they test positive, what's the probability that they actually have it? So we do, the denominator is going to be the overall probability that they test positive. So that's the sum of these two cases. And then the numerator is going to be the probability that they have the mutation and they tested positive. So 0.01 times 0.98. So that's our numerator. And then this gives us a result of 0.2, which is only about 20%. So there's only about a 20% chance that if they test positive, they actually have the mutation. So I'd say that this is not a good decision to make. We can't really, with any confidence, state that this would be a good conclusion. All right, so now we're going to move on to a little bit of vocabulary that we're going to be using over the next couple of lessons, so some statistic and data gathering vocabulary. So first, we'll use this word population a lot, so that's the individuals that you're surveying or studying. A census is when all of the individuals are surveyed from the population. A parameter is just a number that summarizes a characteristic of the population. Sampling is when you only look at some of the individuals of the population that you're surveying. So we're going to talk about different ways we can sample today, or different types of sampling. A statistic is simply a number that summarizes a characteristic of the sample. Numerical data is data that you can represent with a number, such as height or weight. And then categorical data is data that is represented with a description, something like eye color, or type of car, or something like that. So there's some data that's numerical and there's some that is categorical. Okay, so first we're going to look at the different types of samples, because when you're doing a survey, it's actually kind of rare for it to actually be a census. It's, usually we don't have the time or ability to survey every single person in the population. So we'll do a survey. So the goal when you're doing a survey is to get a representative sample. So you can make sure that if you provide some type of statistic, it's valid and it actually represents most of the population that you're studying. So depending on how you sample, some sampling methods can end up to have what are called biased samples, which could result in statistics that give us inaccurate conclusions. So we see this all the time in the news, just the way that statistics are presented. It really depends on how that sampling was done. So here's a few different types of sampling. So a simple random sample is a really good way to sample. It's where each individual in the population has an equal chance of being selected. So this is a really good way to avoid biased samples typically. A self-selected sample is when the individuals volunteer to be part of the sample. So this could lead to some issues in terms of bias. A convenient sample is when individuals are selected based on and how convenient it is, so how accessible they are. Again, this could, depending on the context, lead to biased sample. Systematic sample is when members of the sample are chosen according to the rule. Like, I'm going to pick every fifth person that walks through this door and I'm going to sample them. A stratified sample is when you divide the population into groups, which is a really common thing to do. And then individuals in each group are randomly selected to take part in the survey. And then a cluster sample is, again, when you divide the population into groups, but only some of the groups are randomly selected. And then within those groups, some or all of the individuals are randomly selected to be in the survey. So we'll look at a few different examples and try to decide what type of sampling it is. So here, let's look at what type of sampling method we think is being used and interpret if it could result in bias sampling. So here we have the officials of the WNBA want to know how players feel about some proposed changes to the rules. So they decide to ask a sample of 100 players. So they choose, one way they're thinking about doing it is they choose the first 100 players who volunteer their options. So if you look at the options from the previous slide, this would be considered a self-selected sample, because again, they are volunteering to give their opinions. I'd say for this, it's very likely that you would get a biased sample, because I think that players that are more likely to volunteer their opinions probably have stronger opinions about things. So again, it could be that you're only hearing from people that have a strong opinion about one thing or only have one opinion. So this may not be the best way to sample the players. Another option is that they randomly choose 3 or 4 players from each team in the WNBA. So this would be considered a stratified sample, because the population is being placed into groups, which is the teams, and then every team is being surveyed, and from each team they randomly choose 3 to 4 players. So I'd say this would be a pretty unbiased approach to collect the sample, because again, all of the teams are being surveyed, and within that the players are chosen randomly. And lastly, officials have a computer randomly generate a list of 100 players from the database of all players. So this would just be considered a simple random sample. And since every player has the same probability of being picked by this random number generator, I'd call this a pretty unbiased approach. And I think that would be another good method to consider. Okay, let's look at another scenario and do the same. So this says administrators at Saratoga High School want to know if students think healthier options should be added to the lunch menu. So here's a few different ways that they're thinking about surveying students. So they survey every 25th student who walks through the quad during lunch. So this would be a systematic survey or a systematic sample. Because they have created this rule that every 25th student they'll survey them. So I'd say for this, it's probably pretty unbiased, because again, it's just students that are walking through the quad. Students of all ages walk through the quad. Students that buy lunch or don't buy lunch walk through the quad. So I think this would be a pretty good way to collect information from students. The second option is they survey the first 50 students who get in line to buy lunch. So I would call this a convenience sample or survey. And it's the convenience because this would be the easiest thing to do. You just say, okay, the first 50, I'm going to sample you. So for this, I think that we could definitely have some bias here, because first of all, if they are in line to buy lunch, then you're only looking at students who buy lunch. So you aren't looking at any students that are not buying lunch that day. And it's very possible maybe they aren't buying lunch because they don't have any healthy options. So again, you're really limiting the pool of students that you're sampling. And the last one, they sort the students by grade, randomly select 2 of the grades, then randomly select 25 students from each of those grades. So I would call this a cluster sample, because again, they're putting them into groups. And then they're randomly picking two of those groups and then randomly picking students from each group. So I think that this has the chance of having some bias, because what if the groups that are picked, what if the grades that are picked are maybe juniors and seniors? So maybe those are students that, because they can go off campus for lunch, they don't really think about whether or not they want healthier options, or maybe it's not affecting them as much, so you're missing out on the kids that actually would need to use the cafeteria to get lunch. So I'd say this probably wouldn't be the best method to sample. All right, so now we're going to move on to some different concepts that describe the center spread and the shape of distribution of our data. So first we're going to start with what are called our one variable statistics. So some of these may seem familiar to you. For example, mean. So we know the mean is the sum of n data values divided by n. So you add up all the values in your data and you divide it by how many values there are. Sometimes it's denoted by this X bar. Probably a more common thing that you'll see is this mu symbol. Looks like this. You'll see it down below as well, which we'll get to in a second. But I think this is probably the more common way you'll see the mean, so with that mu Greek letter. The next word you probably also know, the median, is the value in the exact middle of all your values when they're listed from low to high. And if there's an even number of values, then you have to take the mean of the two that are in the middle. Now, this next one is probably new. It's called the interquartile range, or we call it the IQR. So the IQR is by definition Q3 minus Q1, but you do need to understand what Q3 and Q1 are. So if you have all your values from low to high in ascending order, right, we know that the median is right in the middle. We could also call that Q2. So the first quartile, which is Q1, is the median of the lower half. So it's kind of that quarter way point. And Q3 is the median of the upper half, right here. So if you do Q3 minus Q1, you get your interquartile range. And again, this is just the ones that are in the exact middle when they're arranged from low to high. And then another thing that we're going to start talking about today and then later on this unit is what's called the standard deviation. So here's kind of a technical definition of it. It's the square root of the mean of the squared deviations or differences from the distribution's mean. So what in the world does that mean? So first of all, it's usually denoted with this symbol, which is lowercase sigma. So that's sigma. Remember, we've done sigma notation before, like summations, but this is the lowercase sigma, so it means standard deviation. So what does all of this mean? Well, you find the difference between each value and the mean, and then you square that difference, and then you essentially take the sum of all of those squared differences and then divide it by the number of terms. So you're taking essentially the average or the mean of the squared differences, again, between the term and the average. So this is something today we'll practice one time calculating it by hand, and you could also use your graphing calculator to find this for you. So we'll talk a lot more about standard deviation in a couple lessons, but essentially we can use a standard deviation to help us determine about how much of our data is within a certain reach of our mean. So this is what's called a normal distribution curve. So you could see here's our average right in the middle, and then you could see you're adding a standard deviation, and then 2 standard deviations, and then 3, and then you're subtracting 1, you're subtracting 2, you're subtracting 3 standard deviations, and it tells you how much of your data is within there. But again, we're going to focus more on just the act of finding the standard deviation today, and then we'll talk more about how we can interpret it later this unit. All right, now we're going to move on to talk about shape of distribution of data. So this first shape here is called a normal or a symmetric distribution. So you can see that if you cut your curve in half right here vertically, that it's symmetrical on either side. So something like this, that middle point would be our mean, right through here. And again, we kind of have the same amount of data on the right and the left, and it's acting in a symmetric way. And this would also tend to be where the median and the mode of all of our data is. But if you look down at these two skewed distributions, so we have 2 cases. It can be skewed left or skewed right. So I know that this one, looks like all the data is on the right, but we call it skewed left. So you kind of look for where the tail is. We would also call this a negative skew. So for something like this, it's a skewed left because actually our mode is here. So that's the mode is the term that's used the most. So that has the highest number of occurrence. And then our median is here. And then our mean is actually to the left of that. So whenever your mean is actually to the left of your of your median, we say that it's skewed left or it's a negative skew, but really you could just look at the shape of the curve. And then when you have something that is skewed right, it looks like this. The tail is kind of on the right. For something like this, again, your mode is right here, so the one that's used the most, and then your median is here, and then your mean is actually here. So the mean is to the right of the median. So we call this skewed right, or we could also call this a positive skew or skewed positively. And again, if you make maybe a histogram of your data, you can kind of look at the shape that it makes to see what type of distribution you have. And then also there's a uniform distribution. So here notice that there's no type of kind of bell curve. This is just when all of your data has the same frequency, it just makes this box shape. So that'd be a uniform distribution. All right, so we're going to first try to calculate a standard deviation of some Algebra 2 Honors quiz scores by hand. So first thing we need to do when we're calculating a standard deviation is we need to find the mean of our data. So remember, to do that, we add up all of our data. Plus 50 plus 43, and then we divide it by how many terms are in our data, which in this case is 8. And then here we get approximately 45.9. So that's the mean of the quiz scores. And then remember, to calculate that standard deviation, we need to do the square root of the average of the squared differences between each data point and the mean. So maybe first we can find the squared differences. So we'll do 49 minus 45.9 squared, 42 minus 45.9 squared, 45 minus 45.9 squared, 46. I know this is a little bit tedious, which is why we're only going to do it by hand one time. So again, I'm finding the squared differences first. Okay, so I'll find all of those. All right, so here I have those square differences, and then we're going to take the mean of all of these numbers, and that's going to give us the standard deviation. So the square root of the sum of all of these I need to zoom out a little bit. So I do the sum, I divide that by 8, and then I take the square root of that quotient. And we end up with a standard deviation of about 2.9. So again, I will show you guys how you can do this in your graphing calculator. It will be much easier and quicker, but I think it is important that we've at least tried the formula and done it by hand at least once. So our standard deviation is 2.9 from that mean of 45.9. All right, so now we're going to try to look at some data, and we're going to look at some one variable statistics and then some different visual representations of the data in our graphing calculator. So first, you're going to need to take a moment and enter in all of this data to your calculator. So the way you do that is you look for this button that says Stat, and when you click it, you will automatically be in, it will automatically be highlighted the word Edit, and then the first option of Edit says Edit, so you hit 1 or Enter, and then it will lead you to your, where you can enter your data into a table. So go ahead and enter this into L1, L2, and L3. You might need to pause video to do this, and it will just go down the column. Now, once that is entered, we want to calculate these one variable statistics. And of course, if we do this by hand, it's going to take forever. So it's important to know how to do this on your calculator. Now, to do this, again, we're going to hit that Stat button first. So you're going to hit Stat, And then you need to scroll over to the right to where it says calculate. And then from there, you'll see that the first option says option 1, one variable stats. So you hit that, and then it's going to ask you a couple things. It's going to make sure that it's pulling the data from the right place. So for this one, you're going to want to make sure that under list, it says L2. And you can get to L2, you can change any of them, but again, we're changing list to L2 by hitting second and then 2, because if you look right above it, it says L2, and that will replace it. And then you just hit enter, or you have to scroll down to calculate, you hit enter, and it will show all of these things for you. So first, it does show the mean here. So the first thing you'll see at the top of your list, it will be about 3.503. So we'll say 3.5. Now to find the median, you actually need to scroll down. So you're going to scroll down, and eventually you see that the median is also 3.5. And then we want the standard deviation. So you look for that mu symbol with the x next to it. And we'll just round that to the nearest hundredth. So we'll say 0.14 for the standard deviation. And then if you scroll down even more to find the IQR, remember the IQR is Q3 minus Q1, and it tells you what those values are. So we have 3.6 minus 3.4, so our IQR is 0.2. All right, the next thing I want to do is to create a histogram of these same baby weights so we can kind of see a visual representation of the distribution of the data. And then that will help us determine the shape of the distribution. So to do this, we need to first go turn on our plot. So you have to do second and then y equals. So you see above it says stat plot. So that's your goal, is to hit that stat plot button. And then once you hit stat plot, you could hit option 1 for plot 1. So you could hit enter for that. And first we want to turn it on. So make sure you turn it on because the default is set to off. And then for the type, you can look through and choose what you would like for this one. So I just added a little picture here of the one that you should select. It's a little hard to see, but it's this one right here in the first row, but the third one to the right. So this is our histogram feature. Notice that plot 1 is turned on. And then for XList, you want to make sure it says L2. So to change that, you can see L2 is right here. It's right above the number 2 again. So you could hit second 2. I believe we did that up above for the one variable stats. And then you want to make sure that the frequency says 1. And then you hit graph. And then you should see something eventually that looks like this. So to make yours look like this, you're going to need to do a couple things. You're going to need to adjust the zoom. So a good tip when you're doing these types of things like making a histogram, when you hit zoom, option 9, if you scroll down or you just hit the number 9, it says zoom stat. That's a pretty good place to start. It kind of centers the window around your histogram. And then another thing that I would do, if you go into the window, I would change the X scale. So it says X SCL. I would change that to 0.1 because that's like the scale of the units that we're in. And then that will show, like each bar represents just 1/10 of a unit. So it will represent all of our data without having to round it or lump any of it in between. So again, I would change the zoom to zoom stat, and I would change your window, in your window, I would change the X scale to 0.1. And then if you hit the trace button, you can kind of move along the different bars of your histogram to see how many elements are in each column. So you can see here my little cursor is moved over to here, the value 3.5, and I can see that there are 6 data points that have the value 3.5. So again, that trace button, once everything is set nicely, you can kind of move along the different bars of your histogram. So you can see in our histogram that we do have a pretty normal curve here. It looks very symmetric. So I would call this a normal distribution. Okay, the last thing we want to do is we want to create a box plot, which is also sometimes called a box and whisker plot, of the weights. And we're going to look at that and we're going to see if we can interpret what it means. So again, to do this, you have to go back to the stat plot, and so you could turn on the box plot. Okay, so the box plot here, actually I'm going to zoom out so I can leave that one for us to reference later. I'll do this. The box plot option that we want to select is this graph right here. So it looks very similar to the one next to it, but we want this one right here in the middle of the second row. And again, you're going to want to make sure that your X list says L2 when you do it. And then when you go to graph it, I would do zoom stat again. So then hit graph once that's selected. And what you should end up with is a graph that looks like this. So when you look at a box plot, what do the different things mean? So the number on that line, that vertical line in the middle of your box, this represents the median. So this is our median. And if you do the trace button, you can like scroll over to any of these lines and it will tell you that the median is 3.5. And then the edges of your box here represent Q1 and Q3. So here it says this is Q1, which is 3.4, and it says this is Q3, which is 3.6. And then if you scroll over to either end of our box plot, it tells you the minimum value, which is 3.2. And then it tells you the maximum value on the right, which is 3.8. So again, this one, it's not about where the mean or the average is, but it is about the breakdown when you list your numbers from low to high. So when you look at this, you can see since the box plot, the box is centered in the middle, we could see that our median is centered in the middle of our box. We can see just from this that this would actually make that it's a normal distribution. So when you see something like this that is very symmetrical and centered, it ends up making a distribution that looks like this. So I know that was a lot of steps on the graphing calculator. It's a little bit hard for me to show in this video. So things that you should know how to do. You should be able to calculate the one variable stats. You should be able to create histograms, and you should be able to create box plots. So if you need to review any of those things, there's tons and tons of videos online, or you can come ask me in class. All right, let's try another one together, but this time we're going to be doing it for the mom's age, which for us is that L3. So we're going to need to do the same thing. We're going to go to Stat and then scroll over to Calculate. And then we're going to hit that one variable statistics, but this time we need to make sure that we change our list to L3. So we can hit second 3 and then scroll down to calculate, hit enter. So for this one, we should see a mean of 31.15. And then if you look for, again, this symbol in your calculator, that's the standard deviation we're looking for. So we get about 2.61. If you scroll down on your calculator, you can find the median, which is 30.5. And then you could see that if you do Q3 minus Q2, it's 32.5 minus 29, so 3.5. So right off the bat, you might notice that our median and our mean are a little bit different. Our IQR is a little bit larger than the last example. Of course, that all depends on the data you're working with, but I think the best way to get a better idea of the distribution is to, again, look at a histogram. So again, for this one, we need to go to stat plot. So you hit second y equals, and then we have our stat plot already turned on. We want to make sure we go back to histogram, and we want to make sure we change our list to L3. So it should look like this. Again, our histogram should be highlighted, and we want to change this to L3. And then once you hit graph, the first thing you're going to want to do is that zoom stat. So remember that's zoom, the zoom button, and then just hit the number 9, which is zoom stat. And then we are going to need to go to window again and change the scale of our x-axis, so the x scale. If you look at the way that our data is represented for the mother's age, it's just counting by ones. So let's just change the x scale to 1. So when you see that, you should get a graph that looks like this. And if you hit the trace button, you can kind of scroll and toggle between the different data points to see the frequency of each one. You'll see over here there's actually some ages where you don't have any, and then you have the one mother that was 39 years old. So if you look at this data, it gives you an idea of the distribution. We could see that the shape of the data is kind of like this. So remember, we say that this is actually skewed right. We say that this is skewed right or positively skewed. And again, that was kind of evident in the fact that our mean was actually to the right of our median, so that also shows that it was kind of skewed right. But another way we could do this is by looking at a histogram of this data. So same idea here. We need to turn on our histogram. So you go back to second y equals the stat plot, and then you just want to make sure the box plot is highlighted. So it should look like this. So you can see right here is that box plot picture that you want to make sure is highlighted. And then from there you can hit graph. If you want to do another quick zoom stat, it will kind of center your box plot. But you should end up with a box plot that looks like this. All right, so here you could see that your box plot is actually shifted over to the left. So again, we say that this is another way of showing that it's skewed right. You can see here's our median right here, and then our Q1 and our Q3, and you can see that it's all shifted a lot closer to our minimum value than our maximum value. So that's another way of kind of determining the distribution of this data. All right, so I have one last one for you to try on your own. So please do this entire process again, but please do it with your the data of the birth month. All right, go ahead and check your work here. So for this one, you actually see in your histogram that you actually get more of this shape here, which is, remember, what we called a more uniform distribution. And if you think about it, for the context of this, if it's the month that the baby was born in, there's really no reason for there to be one month where there's more babies being born than any others. It really should be about uniform across the year, so you wouldn't really expect to see that bell-shaped curve for this set of data anyways. And additionally, I don't know if the mean, median, and the standard deviation tell us as much about this, because again, it shouldn't really matter when in the year you're born. It should be kind of the same probability of being born in any month. So again, it's a different type of data here. It's really more of a categorical piece of data that we can represent with a number. So a little bit interesting, but here we definitely would not expect to see a normal distribution for what month babies are born in. And then for your box plot, you can see that the box is centered, but compared to the one in the first example that we did, our box is much wider, right? And we could actually see that the Q1 and the Q3 are really just halfway in between your median and your max or min. So that just shows that your data is really spread out more evenly between the max and min, rather than being kind of condensed around the center. So again, just different ways of kind of trying to visualize what's going on with your data and make sense of the data that you're working with. All right, so that is all for today's video. Thank you so much for watching.